Hello again, my friends. It's the NOLA MATHMAN coming again for another fun math adventure as we attack another math concept and slay our math fears. Unlike Superman, I cannot leap tall buildings in a single bound. I'm not faster than a speeding bullet. But in regards to math,
Superman got nothing on me.
after watching this video, students will be able to multiply matrices. The concept that we're looking at today is linear systems. The skill that we're going to do today is we will learn how to multiply matrices. So with no further ado, let's start with our lesson. So again, we're looking at the concept of multiplying matrices. And so the last time we discussed the whole operation of matrices. We did a few multiplications in regards of scalar multiplication, but we're now going to go into the concept fully. So in our first group examples, we want to determine whether each matrix product is defined. If so, state the dimensions of the product. So in order to properly be able to multiply matrices, the inner terms must be equal. You're going to see what we're talking about in this first example. So we have our first matrix in the form of 2 by 5, 2 rows, 5 columns, multiplied by B, which is 5 by 1. And as you can see, the column for matrix A is equal to the row of matrix B, which we circled. And since they are equal, that means the product is defined. So at this point, we want to determine our dimensions of the product AB. The product will be the outer dimensions, which you can see are 2 and 1. And so the product will be 2 by 1. So the inner product determines if we can multiply. The outer terms determine our new dimensions of the product. So that's the rule we want to use. So we're done with number 1. Now we'll go on to another one. We'll do number 2 now. M, matrix M, has the dimensions 1 by 3. Being multiplied by n, which is 3 by 2. Again, we want to check our inner terms. We have 3 in the m and 3 for n, which is this row. Since both of those are equal, we know that we have a product that is defined. So our product will be mn. That's how we want to write it. Mn together means m is being multiplied by n. I'll write that product in a sec. And the dimensions will be 1 by 2 because that's our 2 outer terms here. And so our new product will be 1 by 2. And in a few minutes, we will learn to actually do some products so you can see this process at work. So we're done with number 2. Now again, what this gets you accustomed to doing is figuring out the products and to see if they're defined, because they're not always going to be defined. So next problem we're going to do is number 3. B is 3 by 2 matrix multiplied by A, which is a 3 by 2 matrix. Now when you look at these two inner terms, they're not equal, so that means the product is not defined. And so we cannot multiply these two matrices, which will show up here in a second. So this matrix here, the product is not defined because the inner terms 2 and 3 are not equal. And since they're not equal, we cannot multiply the matrices together. So this example where the dimensions are not, you cannot get a product. So it's good we did an example like that so you can see an example where the matrices cannot be multiplied. So now we're going to actually find the actual products of two matrices instead of looking at the dimensions and determining whether they can produce a product. we're going to actually find the product. So we have some problems here that we present. We have here problems 7 through 10. And so we're going to pick one of those examples and we're going to do a problem. So which one do you think the NOLA Mathman will do? Let's see. It's taking them a little while to figure it out here. So he wants to make sure we do a problem that is useful. Oh, so we'll do our first problem. So we have a matrix horizontal 3, 2 multiplied by a vertical matrix of 2, 1. So the first thing we have to do is do what? We have to identify the dimensions of the two matrices. The first matrix will be 1 by 2 because it's 1 row, 2 columns. The second matrix is 2 by 1 because it's 2 rows and 1 column. Since the two inner terms are equal to 2, we know that we will be able to multiply and get a product for number 7. So what we will do is we know that our product will be 1 by 1. So what we do is we start setting it up. The way it works is we take the first term and multiply by the first term, first row, 3 times 2. We take the second term in row 2 and multiply by the second term in the first column, and you get 2 times 1. 3 times 2 is 6, 2 times 1 is 2, 6 plus 2 is 8, and that is a 1 by 1, which again, 8 is a 1 row, 1 column answer, which is what we're supposed to get. So we're done with number 7. So let's see now what we do. So hopefully, the more you do this, the more you'll get accustomed to working out the rows and columns. So in number 8, we have 2 rows, 2 columns, 5, 6 in the first row, 2, 1 in the second row. And then in the second matrix, we have 2, -5 in the first row and 3, 1. So we have to determine our dimensions. The first matrix is 2 by 2. Second matrix is 2 by 2. The inner columns are equal, 2 and 2, so we know we can produce a product. So again, the way it works, we will have a 2 by 2 matrix that is the result of multiplying these. And so our first row, first column will be determined by taking 5, multiplying by 2, and we will add that to 6 being multiplied by 3. You take the first term, multiply the first term, the second term by the second term in the second column. So now we're going to take first row, second column, 5 times -5 times 6 times 1. And so we have our first row of products complete. So to get our second row, we will take the second row times the first column, 2 times 2, plus 1 times 3, which should pop up in a second here. And then we take our second row and multiply by our second column, and we'll have 2 times -5 times 1 plus 1 times 1. So now we want to simplify these products, and we will have our new matrix that's the product of these two. So as you can see, first row, first column, 5 times 2 is going to be 10. 6 times 3 is going to be 18. A lot of times you can write the product right above the work there, like I'm doing, like the NOLA Mathman is doing. That gives you 10 plus 18 in the first row, first column. First row, second column, -25 plus 6. Second row, first column, 4 plus 3. And second row, second column, -10 plus 1. So once we simplify that, we will get in the first row 28, -19. That will be our first row. Our second row will be 7 and -9. And so that will give us our final product. So again, first row 28, -19. And as you can see, it's a 2 by 2 matrix as we wanted. In the second row is 7, -9. So we're complete with number 8. All right. So hopefully, again, the more you do these multiplication problems, find the products, the easier it becomes. So let's see where we go next. We'll now do number 10. So we write that vertical column of 3, -2, multiplied by 2 by 2. First row is 1, 3. Second row is -1, 1. So again, the first thing we have to do is get our dimensions. What do you think of the dimensions of the first matrix? That's 2 by 1, 2 rows, 1 column. 2 by 2 is the second one. The middle terms are not equal, so we cannot find a product for number 10. And so we would say it's no solution or not possible. And so number 10 is done because you can't multiply since the middle terms again are not equal, which means we can't find a product. So good, we did an example that does not produce a product. It's good to be able to identify those, and I'm sure you'll see it more of those in the examples you do for your homework. You'll see some examples like that. So now we'll go to another group. We'll go to problems 11 through 14, and we want to find a product if possible. So which one do you think the NOLA Mathman is going to do? Well, let's do number 12. There we go. So we have first column -1, 3, that vertical. And then our next matrix is a horizontal matrix of 2, -3, and 2. So we write down our dimensions. The first matrix is 2 by 1. The second matrix is a 1 by 3. So we compare the two middle terms. They're equal to 1, so we know we can find a product for this particular example. So we will find a product, and our product will have what dimensions? Well, yes, it'll be the outer dimensions, which are 2 by 3. So what we want to do now is set up our products. So again, the first thing we do is we will take the first row times the first term in the first row times the first term in the first column. So we will have -1 times 2. That should be our first product. That should pop up, which you will see here in a sec. First row, second column will be -1 times -3. And then that last row, first row, third column will be -1 times -2. The second row, first column is 3 times 2. Second row, second column is 3 times -3. Second row, third column, 3 times -2. So once we get that, we will have our new product. Our first row will result of -2, +3, and 2. And our second row will be 6, -9, and -6. And so we have completed. And again, the answer has to be in 2 by 3 form. And this is what we have here. We have 2 rows, 3 columns, which lets us know that we multiplied the products correctly. It's very important when you do this to be careful with your sign rules. Remember, negative times positive, unlike signs, will give you a negative product. And like signs, negative times negative or positive times positive will produce a positive product. So as you can see, that's very important when you're doing your products. So let's see what the NOLA Mathman does next here. So we're gonna do number 12. We're gonna now do number 13. We have a vertical column of 5, 6, and -3 being multiplied by another vertical column of 4 and 8. Vertical matrix, I'm sorry. So the first thing we're going to do is write out our dimensions. The first matrix will be a 3 by 1. The second matrix will be a 2 by 1. Since the middle terms are not equal, we know that this product is not defined or not possible. So that one's very easy to do. Whenever the product is not defined, the work goes very quickly. So we're done with number 13. So let's see if the NOLA Mathman is going to do number 14. Let's see how that works. Oh no, we're gonna do another group. So now we go to problems 15 and 16 here. And which one you think we should do? Which one you think is the most challenging? Usually the NOLA Mathman wants to attack the most challenging problem. So which one do you think is most challenging? It looks like number 15 is. So let's see how that works. See what the NOLA Mathman does here. So we'll see here. I think we should do number 15. That one looks a bit challenging. Oh yeah, so that's what the NOLA Mathman decided too. We think alike, great minds think alike. So in this first row, it's what we call a 3 by 2. You have -4 and 4 in the first row, -2, 1 in the second row, 2, 3 in the third. The second matrix is a 2 by 2. First row, 3, -3, and 0, 2. We want to put the dimensions. Dimensions of the first matrix is 3 by 2. The second is 2 by 2. The middle terms are equal, so that means we will have a product. We can create a product for these matrices. That will be basically a 3 by 2 matrix. So let's get busy. So again, the way it works is we take the first term in the first row, first column, and multiply by the first term in the first column of the second matrix. So we will have in our first row, first column, we should have a product of -4 times 3 plus what? You're right, 4 times 0, exactly, just what you thought. So that's what we're gonna get. Our second row, first row, second column will be -4 times -3 plus 4 times 2. So that will complete our first row. Our second row, first column will be -2 times 3 plus 1 times 0. And as you can see, well, you'll see a pattern by the time we finish. Let's see if you can see the pattern. And the first term obviously will be -2 times -3. And then you will have 1 times 2. And you should be able to see from the first row of work the pattern. If you look in the columns, the first column, the second terms are always the same in the second term. And if you look across the rows, the first and the second terms are the same. So it's a very interesting pattern. So our last row will have 2 times 3 plus 3 times 0. And we'll have 2 times -3 plus 3 times 2. And as you can see, that's our pattern. So at this point, we will simplify each of the products and we will get a new matrix. So we can write the work above like you see here on the screen. -4 times 3 is -12, 4 times 0 is 0. -4 times -3 is 12, 4 times 2 is 8. That's the first row. Second row, -2 times 3 is -6, 1 times 0 is 0. -3 times -2 is 6, 1 times 2 is 2. Third row, 2 times 3 is 6, 3 times 0 is 0. 2 times -3 is -6, 3 times 2 is 6. Now we simplify the sums and our first row will be -12 over -1220. Second row will be -6 and 8. And the last row will be 6 and 0. And that should be our final product for this matrix, which we will circle. As you notice, the NOLA Mathman tends to circle the final answer. We want to make sure that the matrix is a 3 by 2, which it is. And so that lets us know that we've done our products correctly. Anytime the dimensions are the same as the outer dimensions, that means you have properly multiplied the products. So let's do a different example here. We erase the work here first. So again, I want to give a shout out to the Who Dat Nation. As a proud NOLA man, we love our Saints, and so as you can see, I got my little Saints jersey on. So I want to give a shout out to the Who Dat Nation. Love my Who Dats. So let's do number 16 here. We have a 2x3 matrix 0, 1, 1, 1, 1, 0, and they have a vertical matrix of 2, 2, and 2. So the first thing we have to do is write out dimensions. The first one is 2x3, the first matrix. The second matrix is a 3x1 matrix. We compare the middle terms, they're both equal to 3. So that means we can create a product, and our product will be a 2x1 matrix. So our first product will be 0 times 2 plus 1 times 2 plus 1 times 2. That will be our first row. Our second row will be 1 times 2 plus 1 times 2 plus 0 times 2, which will pop up here in a second. So at this point, we will get each of our products. The first row will be 0 plus 2 plus 2. The second row will be 2 plus 2 plus 0. And when you add those sums up, we will get a matrix of 4, 4. And since that is a 2x1 matrix, we know that this matrix is a correct product. And the board there illustrates what we're saying. You can see NOLA MATHMAN circles the terms there. And unless you know that that is your outer terms, they model the dimensions of the product. So, very good. So, we're done with that. Hopefully you're getting a more solid grasp of the concept of multiplying matrices. The more that you do, the more comfortable and the easier they become. And so, now we're going to go to another set of directions. It says here, using A, B, and C, and lowercase c is equal, which is our matrix, scalar matrix, determine whether the equations are true for the given matrices that are given. So we're going to do one of these. It's almost like a problem to test the properties of matrices, and that's what we're doing. We're going to basically verify matrix rules to make sure that they work with specific examples. So that's what we're doing in this type of problem. So we'll start with number 17. We have lowercase c, which is our scalar matrix, being multiplied by the product of A times C. And then that has to be equal to A, matrix A, times scalar C times the matrix C. So we got to make sure by evaluating that this will be equal to one another, the two matrices. So be a neat example in verifying the properties of matrices. So first thing we do, we put 2, because that is our lowercase c. We multiply that by the matrix A, which is row 2, 1 times 2, 1. We're going to multiply that together, and we're going to multiply A times C. So C is 2x2 matrix with row 3, -1, and row 1, 0. So according to order of operations, you have to multiply A, matrix A times C. So we have to determine the dimensions of the two matrices A and C. They're both 2x2 matrices, which will show up here in a second. And again, since the inner terms are both equal to 2, that means we can create a product here. Now, for the time being, we do this in the grouping symbol. We will multiply by 2 once we get a product for A times C. And so that's the last step. So we don't deal with the 2 outside the matrix until later. So as I was saying, the 2 inner terms are equal, which means we can create a matrix. And so that's what we will do. And so our first row, we will multiply by the first column. So we'll have 2 times 3 being added to 1 times 1. First row, first column. So then we'll do first row, second column, and we will write that in the second row, second column. And that'll be 2 times -1 plus 1 times 0. And so that will give us our first row is complete. Now we'll do the second row, first column. That'll be 2 times 3 plus 1 times 1. And then we take the second row, second column, and that will be 2 times -1 plus 1 times 0. So now we will get those products and add the sums together. First row, first column, 6 plus 1. First row, second column, -2 plus 0. Second row, first column, 6 plus 1. Second row, second column, -2 plus 0. And that will give us a final product, 7 and -2, and 7 and -2. So now we bring down the 2, and we will use that scalar by multiplying all the terms in the 2 by 2 matrix by 2. 2 times 7, 14. 2 times -2 is -4. 2 times 7, 14. 2 times -2, -4. And so the whole C times A times C will give us a matrix of 14, -4, 14, -4. So we will do now, so that's blue, as you can see, that's the product. That's why the NOLA MATHMAN underlines C times A times C, because 14, -4, and 14, -4 is equal to that. So now we have to take the problem on the right side, equal sign, A times the scalar C times matrix C, and we got to see if that's equal to that same matrix we just found on the left side. And if they're equal, then that means that equation is true. So the next thing we're going to do is we're going to find A times, so the first thing we do, so we write that in green. I'm going to use a green pen to denote the difference between the 2. And so the first thing we do is we write A. We put our lowercase c, which is 2. We multiply that by the matrix C, which is 3, -1, and 1, 0. Now, according to order of operation, we have to distribute the 2 into the C. So we leave A the same. We distribute 2 in the C. 2 times 3 is 6. 2 times -2, -1 is -2. 2 times 1 is 2. 2 times 0 is 0. And so it gives us a new matrix of 6, -2, 2, 0. We check the dimensions. Now we have to multiply those 2 matrices. They're equal. So now we're going to create those products to see if they're equal to the first group that we got. So we do that. First row times the first column will give us 2 times 6 plus 1 times 2. First row, second column will give us 2 times -2 plus 1 times 0. Now, next we will calculate the second row, first column, which is 2 times 6 plus 1 times 2. And then we will do the second row, second column, which is 2 times -2 plus 1 times 0. Which should pop up here any second. Now we simplify those products. The first row, first column will be 12 plus 2. First row, second column, -4 plus 0. Second row, second column, 12 plus 2. Second row, second column, -4 plus 0. And then once we do that, we create our final answer for this matrix. which will be, should pop up here in a second. We can see it already while the NOLA MATHMAN is erasing. We will get 14 negative 4. And we will get 14 negative 4. Now, that is the same value that we calculated for C times matrix AC. So basically, we know that these are equal, and so this equation for number 17 will be true, which is great. That's what we were instructed to do, to determine if they're equal or true. And again, now we're going to write the answer we got in blue for the first answer. And since these two are equal, we know that this equation is true for number 17. So that was a very fun problem where you get to verify the properties of the matrices. So that looks like that's it for us. I think that is it for the concept of multiplying matrices. So again, after watching this video, you should be able to multiply matrices in a variety of ways. Again, the NOLA Man, we have done another math adventure. So until we meet again, the NOLA Man will sign off. Have a blessed and great day until we see each other again. Bye-bye.